Hi there! We'll be implementing the individual risk model to value an insurance portfolio. The team members for this project are Iker Larios, Carla Duron, which is me, Mayela Lizardo, and Carlos Martinez. We will be working with the individual risk model applied to an elementary topic of long term life actuarial calculations. We have a portfolio with a 60 whole life insurance policy for people of 40 years of age. The sum insured is 1,000, and they ask us to use the inverse transformation method and the Monte Carlo simulation method to find the smallest k such that the probability of the insurance company ruins is less than 5%. We will be using the mortality table you see on my right of the people from different ages and the probability of death for each of the ages. But we will be focusing, as said before, in the age 40 with a 3% of discount rate.
Now in this slide, we see that K represents the future lifetime spanning from birth, age 0, to age 60. Now, when calculating the probability that an individual at age 40 will survive for K more years, it's quite straightforward. We simply subtract the likelihood of a 40-year-old passing away within that time frame from 1. To determine the probability that K at age 40 equals K, we multiply Kp40 by Q40 plus K. Think of it as a probability mass function where the sum of this column adds up to 1 as it should. Moving on, we compute b to the power of k plus 1, which is obtained by taking 1 and dividing it by 1.03 raised to the power of k plus 1. This assumption reflects the scenario where an individual's life ends at the end at the close of the year k of the insurance coverage. Now, what we are calculating here is the actuarial present value of a monetary unit payable at the end of the insured person's lifespan. This involves a recursive process where we calculate the actuarial present value for each k value, considering the probability of a person passing away in that specific year divided by the discount factor. We also factor in the probability of the person surviving, again divided by the discount factor, and then multiply the result by the present value of the insurance in the following year, which is assumed to be zero. For the collection of variance, we square b to the power of k plus 1 and follow a specific formula. Subsequently, we sum the product of that column with the mass and subtract the square of the expectation. When it comes to determining the premium, we use the expectation plus k times the square root of the variance, which we calculated lastly, and to end, we'll address the specific k value to we'll use to calculate the premium in a later point.
With the value of the single net earned premium and the variance, we can use the inverse transformation technique to simulate a random scenario where and the unit profit is paid. The losses are simulated for the group of 60 people, wherein the ring minus 60 for the premium. If the losses is negative, what it really see is a profit. Repairing this process in the background is a Monte Carlo. We obtain the probability of the ring. If we adjust the parent key to less than 1, we can obtain the probability of the ring with 50%.
Here we have the following table, which we find the interest rate on the left side corner as well as the sigma that is used. On the other hand, this table extends to 60 people, which is the number that we generated randomly of age simulations. The AXLN is added to the premium one and then multiplied by the square root of the variance, giving us the premium 2. Subsequently, the variation between premiums is calculated with a division, and finally the table shows the premium folio and the loss of the simulation compared to the sum of the premiums. If it's a 0, it's safe, and if it's 1, it's a loss.
After running the simulation for 60 people aged 40, we get that the probability of ruin would be of 3.386%. With this, we learn how much we should charge for a person of 40 years of age and with a death probability or mortality probability like the one given on the table that we were using. By doing this project, we learned how both methods can be implemented to calculate the premium for a person of a certain age in order to avoid ruin. Thank you.